Hi students, this is Srinivas, SMS ZPHS Dabilpur. Today we are going to learn about one important topic in 10th class mathematics, that is polynomials. Let us see about polynomials. Polynomials. Okay? So let us discuss about these polynomials today. First of all, we should know the meaning of the chapter. What is the meaning of polynomial? Let us see, dear students, listen carefully. Polynomials. This is the combination of two words. If you observe carefully, this polynomial is combined with two words. What are those two words? Let me explain. See, there is a word poly. This is poly. And another word nomials. Nomial is nothing but monomial. Nomial is nothing but monomial. See, one is poly, another one is monomial. The combination of these two words is polynomials. We know about poly. Poly means many, or this is more. This is more. Poly meaning is more or many, anything. Plus, we know about monomial. Already we have learned in 9th class and 8th class also. What is monomial? Monomial is a single. That is a single term. This is monomial. Is nothing but single term. Single term is called the monomial. So, polynomials has got this meaning. What is that? More monomials. So, polynomial is nothing but more monomials. So, we are going to learn about more monomials. What is more monomials? More, that is many. Monomial. What is a monomial? Let us recall from 9th and 8th class what we have learned. Monomial. Let me once again recall this monomial. Monomial has got a particular definition in mathematics. Monomial is a single term. There are many single terms, numerical terms, algebraic terms, like that. Many single terms we can write. Whereas we discuss about monomial, how to define this monomial. See, monomial is an algebraic expression. We know about algebraic expressions. Before that we have learned about numerical expressions, algebraic expressions, all these. So, algebraic expression. An algebraic expression which is having a single term is called monomial. But there are certain conditions to become an algebraic expression is a monomial. What are those conditions? See, I'll write, observe carefully, algebraic expression. Algebraic expression which is in the form of a into x to the power n. Listen carefully. We are discussing about monomials. If you know clearly about monomial, only then we can easily understand about polynomial. So, an algebraic expression which is in the form of a into x to the power n under certain conditions, that is a is a real number and n is a positive integer. This is very, very important. A must be a real number. We know about real numbers. integers, natural numbers, whole numbers, rational numbers, irrational, all these numbers comes under real numbers. So a can be a real number and n is a positive integer. We know about the positive integers 1, 2, 3, 4, 5 plus. This is not a negative, positive 1, 2, 3, 4, 5 and so on. So n can be a positive integer. So when we apply these two conditions to this algebraic expression, then we can get a polynomial, isn't it? So let us apply these conditions. For example, a is a real number. Let us take a real number 5. X is a variable and whole to the power n. X to the power n. N must be a positive integer. Positive integer. 3 is a positive integer. So 5x to the power 3. That is a monomial. In the same way, you can give a real number, for example, minus 7. Minus 7 is a real number. X is a variable and its power must be positive integer. Minus 7x to the power 5. This is a monomial. Like that we can write infinite number of monomials. But simply, if you see this, it's very easy to understand that this is a monomial. Yes, it is correct. When we go deep, let me explain some more examples. For example, minus 5 by 2 into x to the power 2. Minus 5 by 2 x square. It is a monomial. Like that, since it is a single term, it is a monomial. Now, if you take, for example, 1 by x. If I ask if whether 1 by x is a monomial or not, if I ask a question, simply you may say that yes, sir, it is a monomial. Why? Because it is a single term. 1 by x is a 1 by x, 2 by x square or something else. It's a single term. So it's a monomial, sir. You may say like that. But there is an important condition I said. N must be a positive integer. When you see like this, 2 by x square, you may not know that x to the power 2 is positive only, that's why it may be a monomial, like that you may say. But actually, 2 by x square is nothing but it is like 1 by a to the power n. We have formulas in exponential powers. 1 by a to the power n is equal to a to the power minus n. We have to write. So in the same like this, if you write 2 by x square is 2 into x to the power minus 2. 2 into x to the power minus 2. 2 is a real number. A is a real number. X to the power minus 2. Minus 2. What I said? A into x to the power n. N must be a positive integer. But here n is negative. So it is not a polynomial. Sorry, not a monomial. So 2 by x square is not a monomial. This is what is important. First of all, we should recognize what is monomial and then we can go to the polynomials. So this is not a monomial. Do you understand? In the same way, for example, 5. One more example I am telling. Example 3 by 2 into root x. 3 by 2 is root x. Root x can be written as, how to write root x? 3 by 2 into x to the power 1 by 2. X, because root a is equal to a to the power 1 by 2. We have learnt in 8th class exponents and powers. So root x, x to the power 1 by 2. Now this is x to the power n form. But what we said, the condition is n is a positive integer. But this is not a positive integer. That is a rational number which is in the form of p by q. It should not be. Therefore monomials. So this is not a monomial. Now you must have understood about monomial, I suppose. Did you understand about monomial? That's clear. Let us go to the polynomials now. Let us go to the polynomials. What I said about polynomial first polymonomial. That means more monomials. Like this, take more monomials. More monomials means you may ask how many, sir? It may be 2 or 3 or 4 or any number of monomials. But the thing is more 2 or more than 2 times. That's all. More 2 or more than 2 times. So the combination of 2 or more than 2 monomials is a polynomial. Now you must have got it, I suppose. Polynomial. See, polynomial. That means this is the combination of 2 or more than 2 monomials. Already we have learnt about a monomial, so it is very easy to write about a polynomial. Just you can write some monomials and give plus or minus in between that. That's our. That's a polynomial. I'll write one example. You can understand easily. For example, see 3x square. It's a monomial. Minus 5x. That's a monomial. Plus 9. That's a monomial. Now 3x square minus 5x plus 9. It has got more than 2 times. 2 or more than 2. So it is a polynomial. Very simple. That's a polynomial. Let us see some more examples. You are clear now about monomial. It's clear. Let us see some more examples now. I'll give you some more examples about polynomials. Second example. See 3y cube minus 5y. It's a polynomial. But in terms of y, that means y is the variable. Here we can take any variable in terms of x or y or z or p or q, like that. Any English letter we can use for variable. 3y cube minus 5y. You may ask, sir, we have to use only one English letter for a polynomial. No, it's not compulsory. See, we can use like this also. 5x square y minus 3x cube plus 5 by 2 y square. That's also polynomial. This is also polynomial in terms of x and y. X and y are the variables here. The only thing that we have to understand is the power of the variables must be positive integers. This is very important thing in this monomials. And the coefficient, that is a, is a real number. This is called coefficient. We know about coefficient. So 5 is the coefficient of x square y. Minus 3 is the coefficient of x cube. Now this is the coefficient and this is the exponent. We can say that's the exponent. So the exponent must be the positive. That is a polynomial. Now if I ask you to write some polynomials, you can write hundreds of polynomials. Here one more example. X cube plus 1 by x cube plus 9. I gave a polynomial. I mean one algebraic expression I gave. Remember that all these are algebraic expressions. So this is an algebraic expression. If I ask you now whether it is recognize or identify whether this is a polynomial or not. Now we can very easily understand that the power of this variable is 3 because it is x power 3. 1 by x cube, it is in the form of, earlier I said that 1 by a to the power n is equal to power minus n. There is a formula like that 1 by x cube is equal to x to the power minus 3 plus 9. When we observe these three terms, see in this first term the power of the variable is positive, second term power of the variable is negative, third term what is the power of the variable? There is no variable at all. What is the power now? See, there is no variable. So this algebraic expression is in terms of x now. So we can write x power 0. X power 0 is nothing but 1. Any number power 0 is nothing but 1. So 1 into 9 is 9. So the power of this variable is 0. So here is 3, here is minus 3, here is 0. When we observe, one variable power is negative. So this algebraic expression is not a polynomial. This is important. This is not a polynomial. Okay. So we have to identify the given algebraic expression is a polynomial or not. One more example I will give you. See, minus 3 x to the power root 2 plus 5 x minus 11. Minus 3 x to the power root 2 plus 5x minus 11. Now when we observe this one, you may think that yes sir, this is a polynomial. Why? Because the powers of the variable are always positive. See, this is first term. In this first term the power of this variable is root 2. So what you are thinking is this root 2 has no negative sign or symbol. There is no minus. What I am telling is here it is minus 3. Minus 3 means negative. You may think that there is no negative. I mean there is no minus. So it can be an integer or it is a polynomial. But it's wrong. Why? Because this x to the power root 2 can be written as root 2. Root 2 means 2 to the power 1 by 2. 2 to the power 1 by 2 is not an integer. That's not an integer. Plus 5x minus 1. These two are okay. But when you see the first term, there is no positive integer as power of the variable. So this is also not a polynomial. That's also not a polynomial. Okay. Now, for example, I will give you one more. According to this one more I will give you. See, sixth example, root x plus 3 into root x minus 3. If I give like this, immediately what happens is, as I said earlier, root x means x to the power 1 by 2. So the power is a rational number. It's not an integer. So you may say that it is not a polynomial. No, you have to understand carefully. So what I am doing is, we can see here, this is, for example, take it as A and this is B. This is A, this is B. See, same. Now A plus B into A minus B. That's the formula. A plus B into A minus B is nothing but A square minus B square. It is well known. So if you apply that formula here, A square minus B square. See, now square and root we can cancel. The remaining one is x. Minus 3 square. 3 square is 9. X minus 9 at last we got. It is a polynomial. Why? Because there are 2 or more than 2 monomials. See, x is a polynomial. That's a polynomial. One more last example I will give you. Root x plus 5 into root x plus 3. Can you say whether it is a polynomial or not? Immediately you may say that yes sir, it is a polynomial. That's wrong. What I said in the sixth example, if you observe, root x both are same, and 3, this is also 3, both are same. But here I did not give like that. Here in this bracket this is 5 and this is 3. In this case, if you multiply, there is no application of this a plus b into a minus b. We cannot apply a plus b into a minus b. So what I have to do? Multiplication. Root x into root x, we can say that root x whole square. For example, let us write root x whole square. Root x into 3, 3 root x. 5 into root x, 5 root x. 5 3s are 15. Now square and root cancel. It is x. This is 3 root x, this is 5 root x. Both are similar terms or like terms. We have learned in 7th. So, like terms can be added or subtracted. So, this is 3 root x, this is 5 root x. 3 apples and 5 apples. Simply we can say that 3 apples and 5 apples. Both are plus. 3 plus 5, 8 apples over 8 root x. Plus 50. Now if you observe, this is x to the power 1. The power is 1. Here root x means, as I said, root x means root x is nothing but x to the power 1 by 2. So here is the power is 1 by 2. 15x to the power 0. So when you observe all the 3 monomials, here power is integer, but here this power is 1 by 2. Therefore it is not an integer, so it is not a polynomial. So this is not a polynomial. This is what about a polynomial or polynomials. Like that we can make polynomial by using monomials. So here the main important concept to make a polynomial or to recognize a polynomial is monomial. That's what is main important. As I said, monomial is a into x to the power n. This is main. A is a real number and n is a positive integer. This is about polynomials. So far, till now what we have discussed is about just polynomial. What is a polynomial? How to recognize a polynomial? How we can write a polynomial by using monomials? This is what we have learned. So, children, try to practice it. Try to get some polynomial. Try to write some polynomials and observe which is polynomial, which is monomial, what is the power, whether the power is an integer or a rational number or an irrational number or a real number, like that. So, try to practice it and try to recognize what is a polynomial. Okay? Thank you very much.